the same issue is, for example, now in the Russian-Ukrainian conflict. If you say the Russians are beaten, that's as such a negative thing. But from the Ukrainian perspective, it's positive news. So this is a complexity that has to be factored in function of what kind of research you are doing.
Yes, it's a good remark. This is not included because maybe if you're happy about something, you will make it more clear in your tweet instead of just doing it very neutral. You will maybe use some adjectives that's more clarify your sentiment, your feelings at the moment. So I don't know if anyone wants to add something to that.
Example with the Russian tweet is of course something to consider, but I think to the first question, if it's objectively written, then it should be neutral. I guess if someone a normal person writes about the car accident, they put up an emoji behind it or an exclamation mark, or use some indicators of sentiment. But of course, yeah, it's something to consider.
One more. Applause.
So, hello everyone. My name is Manon Reusens. I'm a PhD student at the KU Leuven. And together with Michael Reusens, Mark Collins, Seppe van den Broeke and Bart Basens, we did a benchmark study in Flemish Twitter sentiment analysis, of which I will talk about today. Just a quick disclaimer, I have a bit of a cold. No worries, it's no COVID. But I apologize in advance if my voice gets weird. Here you can find an outline of what I will talk about today, and I suggest that I'll just get started with the introduction. So, you already heard a lot of presentations about Twitter. Twitter has over 370 million users, and more than 500 million tweets are sent out each day. This is a massive pile of data, which is perfectly suitable for sentiment analysis. And sentiment analysis is a research field that detects people's sentiment, emotions, opinions, etc. in a written text. So you really need a written text for this. And with the start of Twitter and the internet, much more data has become available for this kind of research, such as tweets, but also movie reviews, or hotel reviews, or blogs even. So that actually makes that Twitter sentiment analysis has been booming over the last years. In order to do sentiment analysis, you need some models, and we categorize them into 4 categories that you can see over here. So lexicon-based methods, traditional machine learning models, neural networks, and attention-based models. I will not go into detail about it now. However, it's already important to keep in mind that if you look at other benchmark studies, they often just stay in one category, or they compare 2, but the comparison of 4 is not often done. So that brings me right to my first research question, namely, how are the results affected by using different models in different categories as well, and is increasing complexity beneficial? For example, lexicon-based methods are very simple, and attention-based models and neural networks are very more complex models. And a second research question was, how do different pre-processing methods influence the results of sentiment analysis? So here you can find the pipeline that we used for this study. So we started from a raw tweet, and then you have to do some pre-processing. There are different pre-processing techniques, like removal of stop words, removal of punctuation, and we also categorized them into three different categories. We had text on one hand, in which we only changed the emojis into words, and also deleted the URLs. And then you can see stemming and lemmatization, in which we added some other pre-processing techniques. And the only difference between both is that in one of them we use stemming, and in the other one lemmatization. Stemming just means that you just take the stem of the word. So for example, if you have the word running, you would just have run with double N at the end, so only ing is discarded. Lemmatization, on the other hand, really wants to obtain an existing word as well. So then you use the run, and ning is deleted. After pre-processing, you have to have some vector representations, because your models can't handle real words. So you need to transform them into numbers. And for neural networks and attention-based models, you use an embedding layer. But for the traditional machine learning models, you use other techniques. For example, TF-IDF, which stands for Term Frequency Inverse Document Frequency. In this technique, you just count the word occurrences, and you also look at how many times the word occurs in different documents. So if you have a data set about airplanes, for example, the word airplane doesn't really contain a sentiment, so you don't put too much attention to that word. You can also use word embeddings, like word2vec or fast text. You can use them either pre-trained, or you can train them yourself. However, if you use the pre-trained version, they are trained on way more data than you usually have, so they will lead to better results. The fun thing about this is that you can also do some calculations with it. So you could say that the vector of king equals the vector of queen minus woman plus men, for example. And then onto the models. If you have your vector representations, you can put them in the models. And you can see the 4 categories here as well. So Vader is actually the representative that we chose for a lexicon-based category. For traditional machine learning models, we use logistic regression, XGBoost, and naive Bayes. For neural networks, we use the bidirectional LSTM. And then for the attention-based models, we used a fine-tuned Robert version. About these models, I will not go into the technical details about every model, but I will just give you a quick overview of some advantages and disadvantages of each of them, so that you have a general idea. So for the lexicon-based methods, we used Vader. These methods actually have a dictionary of words, and they have a certain score to each word that's in there. And then they look for these words in your sentence, and then they just calculate a score for your entire sentence. These are very interpretable methods, but also very simple methods. And therefore, it might not fully grasp the complexity of a human language. Traditional machine learning models, as I said, we use logistic regression, XGBoost, and naive Bayes. They are often less of a black box than the neural networks and attention-based models that I will talk about later, and not that computationally expensive. However, maybe they are also too simple. That's something that we will find out a bit later. Neural networks have many parameters. They are very computationally expensive. They are also black box models, so not easily explainable. However, they tend to result in very good performance. And then finally, the attention-based models, they also have many parameters, are very computationally expensive. However, these are the state-of-the-art models that are currently often used in NLP tasks, because they perform very, very well. The evaluation was done with these 4 metrics: the accuracy, macro, F1 measure, precision, and recall. Our classification problem was multi-class, so we had positive, negative, and neutral label, and therefore you cannot just use F1 score, precision, and recall, but you have to use either macro or macro or micro. We use the macro one, and then you just calculate the precision and recall for every label, and you average it. For the F1 and for precision and recall, it's the same. You just calculate the score and you average it over the labels. Then on to the results. Here you can see the best results that we obtained for each model. So first of all, you have the Vader model. That was the lexicon-based one. You can see that it has a accuracy of only 40%, so it performs really bad. Keep in mind that we have a 3-class problem, so the random classification would result into 33%. So it's still better than random, however, not that good. Then the 4 next models are the traditional machine learning ones, and they actually all have quite similar performance, all around 60%, and the logistic regression was the best model. You can also see that 3 out of 4 of the best performances were gained on lemmatized pre-processing methods, and only 1 was the stemmed. So this might suggest that lemmatization would work better than stemming. However, since we only used it on 1 data set, you can't really make a general conclusion. And then the bidirectional LSTM, which was representative for the neural networks, actually has a similar performance to the traditional machine learning models of also only 60%. But remember, it had way more parameters. It's more difficult to train and to optimize. So here you could say that complexity is not really beneficial. However, for the fine-tuned Roberts model, you can see that it has almost 5% a higher accuracy than the best other model, the logistic regression one. So here, the increased complexity is actually really worth using it. So that brings me to the conclusions. So for our first research question, as I said, Robert outperforms all the other models. So it's actually beneficial to use such a complex model. The lexicon-based model performed very bad, and the others were quite similar. Regarding the pre-processing method, lemmatization seems to work better than stemming. However, also if you would look further into the details, you would have seen that if you compared stemming to lemmatization for logistic regression, for example, there was not that much of a difference either. Lemmatization was still better, but it was probably not significant. So that was my presentation. Thank you for your attention.
Thank you for your presentation. So you got an accuracy of about 65%.
Yeah.
Is that good? Is that bad? Or what, I mean, how can we interpret that? Because it's only 65. You can say, well, you have still, if you go up to 100, you have still a way to go. And do you have any ideas how you can get up that accuracy with other kind of models or with other kind of stemming, lemming or lemmatization or whatever, what you're doing?
Thank you for the question. That's indeed a very good remark. 65% is indeed not that high. However, you still have a 3-class problem. So compared to the random classification, it's already quite good. And as you can see, the other models did not perform that well. What you could try to do is further optimize the last model, the fine-tuned Robert one. It also takes a lot of time, and that's actually also something that we will further look into. But that probably can increase accuracy still a bit more. But I think that's the best way to go, because clearly the other models can't really handle it.
for the Robert model, was it what is fed into it? Is it just the text there as well?
Yeah, there is just a text.
Okay.
in it. And no pre-processing was done there because it uses different technique.
Thank you for your presentation. I think it's clear from your presentation, but also the previous presentations, that certain things have impacts, like on model performance, on bias, and I'm really wondering what the impact will be on the eventual statistic that we will make with it. Of course, we need to try it out to see it, but do you have any gut feeling with regards to how much the statistic will change if you do the more complex model, or to do the correction on bias, or to make our training data less biased? Do you have any gut feeling of, will it change? Will it change a lot?
So your general statistics was about giving an idea of the general sentiment of Twitter in Flanders, right?
Yes.
I think for sure that the Robert model actually will give the best best representation of Flemish population. However, I think that if you would just use a simple model like the logistic regression, for example, that it will still be highly correlated with what Robert would predict, for example. So therefore, that's a study that we will still do to see whether there is a correlation in time when using logistic regression or Robert. But I think these will be quite similar, but that's just my guess. We'll see what it turns out.
Thank you.
So thanks for all the presentations. It was very interesting. But as a practitioner for certain things in the domain of defense and security and a lot of other items in that domain, when we are looking at sentiment analysis, we try to connect it with action or with positions. So my fundamental question is, we see a lot of research in the sentiment analysis domain. What's the final purpose of all that? Because, for example, we have done research in Russian influence on Belgian elections, for example. And the people say, look at that, and the sentiment is this, and blah, blah. If those tweets or any other content is not read, and now I put it to the extreme, we don't care whether the Russians or whoever is blowing whatever in the social platforms domain, you see? So what is the connection between the sentiment analysis and something in the real world, or what is the purpose of that? Do you think about that or not?
Yeah, that's also something that we will further look into next year. So you have indeed the Flemish Twitter sentiment. That's then something that is now already displayed on the Statistiek Vlaanderen website, I think. But we will next year also look into whether this actually correlates with survey data, for example, to see how or with which mitigation you can make a statistic for the Flemish people and not just for the Flemish people on Twitter. So that's how we want to actually put it in the real world and make some real conclusions out of it. I don't know if that answers you.
Yeah, if I may add to what Manon said, we started looking into it as an alternative to what we call perceived quality of life, like how happy are people with their life, and the sentiment of Twitter might be an alternative or a complement for that statistic. So that's one thing why we're like what's real about it, what grounds it. We started doing it generally, like a general statistic, but we also want to dive into specific topics, like what's the sentiment regarding to policy topic X or policy topic Y. So then we will filter down the population of tweets to only tweets related to a certain topic. That's the actual goal of why we're doing this research.
Just the thing that we are looking at and technology in our business is looking at, we use, for example, Twitter, but many other different types of sources where similar profiles are used, compared, to get a better perception of what is the real opinion and real actions. You see? Because just by doing it with Twitter, you're still limited. Coming back on the other issue, is it a real person, is it a robot, and blah blah. These are all issues that you try to filter out. So in that sense, we are looking also at the qualification of sources in case there are references to certain hyperlinks. So these are all additional elements you can factor in order to be more precise, more connected to reality. So this is a suggestion that you may consider as well in future research, in expanding and combining different social media platforms with more advanced filtering and consolidation of data from a similar account.
If I just may add one more thing, you say combining different social media platforms. It's indeed a really good idea, but the problem is that for Twitter, for example, there's an API, but for the other, there is not.
Great, and I think, thank you, Manon. Let's give a round of applause. I want to thank all the speakers for the interesting research and the work you've done past year and the great presentations. I want to thank the audience for the interactions, the great questions. As a reward, there's a sandwich lunch in the next room, so feel free to pack your bags and go get a sandwich. May I just ask all the students to come up on stage so we can take a quick picture, if you want. So thank you, everyone.